There are many components that we use to build this solar tree. The first component are 15 polycrystal solar panels, 4 dual-port USBs, 6 individual 12-volt batteries for a battery bank with a switch for manual shutoff, a dusk-to-dawn light control sensor, 16 LEDs, and the center of our circuit, which is a 12-volt charge controller. The setup of our circuit are panels here in parallel, which feed into the input of the charge controller. We also have the batteries in parallel with the digital meter going into the charge controller as well. And from the load port of the charge controller, we have the light sensor and the USB charger in parallel, with the light sensor going in series with the LEDs. The reasons why we have the panels in parallel are so that when we are able to have an increase in current and have the voltage be steady, as compared to series where the voltage would have an increase and the current would be steady. The reasons why we have the batteries in parallel are so that we would be able to charge and discharge the batteries at a uniform rate. And the reason why the LEDs are in parallel is so that we can illuminate the area at a uniform intensity. The USB chargers are also in parallel, so that if you use one port, you would be able to have the same output as the remaining ports. For our design, we wanted to produce a design that projected 468 watt hours, and we designed one that came out to 504 watt hours. The readings that we received from the panels itself, the highest during clear skies were 22 volts, and during cloudy weather, 19.4 volts.
And now to give you a little background on the tree. The core of the tree is a PVC, 4-inch PVC pipe, surrounded by 8 pieces of pressure treated wood cut at a 22.5 or 22.5 degree angles. That way it will give us the octagonal shape that we were looking for. This is a picture of the trunk actually all put together. Here is Mr. Forbes cutting supports for the benches. Here is pretty much the skeleton of the tree, the trunk and the supports for the benches and the table. Here we are starting to install the solar panels. Picture of just truly. Again, here is Mr. Forbes wiring all the panels after all the panels were on top of the tree. In this picture, we wanted to show it so you can see how our batteries are wired in parallel, where all the positives go together and all the negatives together. And that ensures a uniform charge and discharge. Here's a picture of the tree with the box, with the control box already built. Here we have the LEDs already operational. Our controls were already hooked up. We were looking for different ways to see how we could do the table. So we're just trying some layouts. Here's the layout that we came up with. It's a octagonal shaped table with triangle shaped benches. Here's the tree being transported. We're not affiliated with U-Haul. so we're not promoting it. Here's a tree where he currently sits at, right outside the building, where we were so fortunate to allow to be put up. And here's the tree illuminated at night. After the sunlight goes off, goes down, the light sensor completes the lighting circuit and turns all the power on. And of course, this project was not without its challenges. We had to take our polarity. Times were stressful at times. So stressful that Mr. Forbes had to take out a timeout. That between that and the angles that we needed to cut all the wood to get all the shapes that we wanted, he made us think of it.
We learned a lot from this project. One thing that we learned were the components of a solar system and how well they worked with one another. And we also learned how to estimate available energy. If we were given more time on this project, things that we would like to include but aren't limited to are installing Wi-Fi adapters or amplifiers to widen the range of services from the college. Also inverter to power devices that supply off of AC voltage. A bigger setup to charge larger devices, and also shading under the panels to provide shading for individuals sitting under the tree.